like composition because what it does is it forces us to use some flexible thinking. A composition function is what you've seen in the past. It's one function becomes the domain, the range of one function becomes the domain of the other function. So g of f of x is your domain, f of x is your range, right? But what happens with g of f of x? What's the domain now? F of x. And what's the range? G of f of x. So what we're doing here is we're playing around with functions. As we saw in calculus, it's used all the time. Probably the most prominent piece to calculus is understanding chain rule, and it's a composition function idea. But think of the domain, x being the domain becomes the range of f, but that also becomes the domain of g. So let's do one. Let f map 1, 2, 3, 4 to 5, 6, 7. And when you put those together, some of those in f are going to be 1, 6, 2, 6, 3, 5, 4, 7. Okay, and then they do the same with g. So here's f and here's g. We're going to look at g of f and then f of g. Okay. Let's start with g of f. And I don't like GOF symbol. I like G f of x. That feels better to me. I don't know why. So we're going to start with 1, 6. And then when you go 1, 6, the 6, does it have a coordinate in the G? It does. And what's the y? 9. So for 1, g of f of 1, the y value is 9. Look at what happens for 2. 2, 6. 6, is there a 6? Yep. 9 again. Let's try another one. 3, 5. 5, 8. So we get the 8. 4, 7. 7, 8. We get the 8 again. So the domain of g of f is 1, 2, 3, 4, but the range is only 8 and 9. You try this other one, f of g of x. Try that one. Start with 5, 8. What do you notice? In the f, is there an 8 something? No. Let's try 6, 9. Is there a 9 something? 7, 8? No. So this is, we would say, is not defined because the domain of f does not contain the range of g. In other words, the range of g is not the x for f. That's composition. This is the part that you remember the most, though. If we have f of x equal to x plus 2, g of x equal to x cubed, g of f of x, what's the inside, g or f? Of this one, the inside is f, yep. So I like to write the outside first. Write this x cubed first. And then what do we replace x with? X plus 2. And there you have it. You remember how to do this. And then, of course, f of g of x will be different. Inverse. Inverse is if f is a bijection, f is a bijection, the two things it has to have an injection, means it's always increasing or always decreasing, or it passes the horizontal line test. Then the function is invertible, and invertible, f of -1 is our symbol. You're familiar with that. For f is a bijection, then the inverse is a function. And so we can say two things. We can say f inverse of f of x is equal to what? X. And what is f of f inverse of x? What will that be? X. Does that work with square root of x and x squared? Is the square root of x squared x? Is x squared square root x? Yep, works perfect. Find the inverse of a bijection from A and B, where F is equal to this. So if you knew that F was 1, 3, 2, 2, 3, 4, 4, 1, then the inverse is just going to be the what? Reverse. 3, 1, 2, 2, 4, 3, 1, 4. And is this a function? 1, 2, 3, 4. Is it a function? Yep. Is the inverse a function? It is. So then we would say that it's a bijection and it's invertible. Inverse is a function. And just real quickly, to find an inverse, you remember this, but if you have f of x equal to 2x to the 4th minus 5, you would switch the f of x and x. What do you switch them to? What do you switch them to find the inverse? Yeah, x is y and y is x. 2y to the 4th minus 5. Add the 5. Solve for y. This is was one of your favorite things in honors pre-calc because it's so easy. 4th root of x plus 5 over 2 is equal to y. So that technique should be down for you. And then the last thing I want to look at is this. This is the part, are you sleepy a little bit? Wake up for this part, because this is the part that IB likes, and it really brings everything home. Let's say that we're going from 5 to infinity, mapping to the reals. So here's my f of x, square root of x minus 5. Does it make sense the domain is from 5 to infinity? Do we include 5? Yeah. So the domain of this, and I'm even going to write it, the domain is 5 to infinity. And what's the range? Just think of this graph. What's the range going to be? 0 to infinity. You good with that? Okay. Now, when we find the inverse, you're going to switch x and y around. Hi. And then switch x and y around and then solve for y. So in doing that, you're going to get x squared equal to y minus 5. And so x squared plus 5. Should I give Mr. Erickson a Valentine? Okay. All right, so what's neat about this is that you, by the way, students help design that. So this looks like it's a function, doesn't it? X squared. Doesn't it look like that's what we have? And the number one error we'll see in honors pre-calc, students will say that this is the inverse. But why isn't that the inverse? Because it didn't have this domain to begin with. So what we would do is we would erase this, and now this is the part starting at 5, which is going to be your inverse. Now, how could you also predict that? It's a real simple way. Look at it. Yeah, it's symmetrical with y equal x. Beautiful. But there's another way, too, that's really quite easy. Yeah. So the domain is going to be 0 to infinity, right? And then the range is going to be 5 to infinity. So just a little, be careful when you're doing things like this, is that when I find this inverse, it may not be as it seems. It looks like that's the inverse, but it's not. It's not going to be a parabola shoved up 5. It's going to be x squared, and then we're going to have a piece of that. Good. Well, let's see what you can do with these 3, and then we'll go over minimal.